Solving compound inequalities. So number one says graph the following compound inequalities on the number lines. Okay. So A says x is less than or equal to 1 or x is greater than 4. So graphing compound inequalities is just like the same as graphing regular inequalities. Just when there's compound, there's just multiple things to graph. So when we have x is less than or equal to 1, we got a closed circle at 1. And then everything less than that would be this way. Or x is greater than 4, so we would open circle at 4. Everything greater than 4 would be this way. So that's how it would look. So it says so either x is less than or equal to 1 or greater than 4. So anything over here is a solution, and anything over here is a solution, because it could be either or. Okay. All right. B says x is greater than 9 and x is less than or equal to 13. So greater than 9, I'm going to open circle at 9. So greater than 9 would be this way. And I'm not going to draw that arrow forever because it's got to be and less than or equal to 13. So at 13, that's a closed circle, less than or equal to 13. Here it's got to be both. It's between these two, between 9 and 13. Greater than or equal to 9 and less than or equal to 13. The solutions to that sort of inequality would be in between. Okay. I'll let you do C. I'm going to just show D because it looks a little funkier. So this says x is greater than 0 and less than 5, right? Because if you read it this way, this is x is greater than 0, but also less than 5. Okay. So that would show us greater than 0 would be open circle at 0, and less than 5 be like this. So number 2 is kind of reversing this idea. We're going to write the compound inequality for the number line graphs. So A, it looks like we have an x is less than 3 or x is greater than 5. For B, you can either write it with the and concept, or we can kind of do that conjoined compound inequality, and that's what I'm going to do. So it looks like x needs to be greater than 2, but less than or equal to 6. And C is another one of those or. It could be x is less than or equal to -6, or x is greater than or equal to -1. I'm going to jump to 3. So it says solve the following compound inequalities and graph them on a number line. So it's just like we've done in the last lesson, except now there's just 2 of them to solve. So we have 5x plus 2 is greater than or equal to -18, and we have -3x plus 1 is greater than 22. So we just solve them independently and then put them on the same number line. So subtract 2 from both sides, divide by 5. That would be -4. Then we solve the other one, subtract 1 from both sides. Sorry if I'm going too fast. Then divide by -3. And remember, when we divide by negative, that symbol needs to flip the other way. So it's now going to be this way. 21 divided by -3 is -7. So our solution would be x is greater than or equal to -4 or less than -7. That'd be our solution. So greater than or equal to -4 would be this way to the right. And then less than -7, open circle, be to the left. Let me show you B. Again, we're solving for x, so I'm going to add 3 to both sides. So it'll be 4. 1 plus 3 is 4. Divide by 1/2, or you can multiply by 2, but divide by 1/2 on both sides. That would be 8. On the other inequality, I'm going to distribute 3x minus 6 is less than or equal to 27. Add 6 to both sides. We got 27 plus 6 is 33. And then divide by 3. 33 divided by 3 is 11. So to graph this, we're going to say x is greater than 8 and less than or equal to 11. So open circle, greater than 8, we're going this way. But it also less than or equal to 11, close circle on 11, we're going to go this way. So that's what that and looks like. It's got to be greater than 8 and less than or equal to 11. So that's how it will look. Hopefully those two examples were good. Let me show you E, because it looks a little different. So E is that kind of conjoined sort of inequality. So how we set these up, or the best way to set them up, is just to break them up into two separate inequalities. So what I'm saying is make this an inequality and then make this an inequality. So we're just going to break it up. So I'm going to have, the first one will be 5 is less than 4x plus 1. And then I also have the other inequality of 4x plus 1 is less, is less than 21. So I just broke them up. Again, I did this, this, and then this is this. So I just broke it up. Let me erase that, get that out of the way. Okay. And then solve it. So subtract 1 from both sides. On this one, I got 4x, divide by 4, 1. Okay. Over here, subtract 1 from both sides, be 20, divide by 4, 5. And this is really like an and inequality when they're conjoined like this. So remember, we got to read it from the correct direction, or in x's perspective. So when I see this, that says x is greater than 1. It says 1 is less than x, but we're reading from x's perspective. X is greater than 1. So, sorry. Open circle on 1, greater than 1 this way, and less than 5. So open circle on 5, less than 5 this way. So that's what that one's going to look like. Let me show you a word problem. Number 4 says the expression 35h plus 175 represents the total cost of renting a bounce house from a partial rental company for H hours. Shanique's parents are willing to spend between $315 and $420 for the bounce house. A says write an inequality to represent the possible number of hours the bounce house can be rented. Okay. So it already gave us the expression here. 35h plus 175. So that must mean there's like a fee of 175 just to rent it, and then $35 per hour. That's what it's showing us, okay? Because if later on in some of the other ones, you might have to create that expression. But the idea is it's $35 per hour plus 175 for some other fees. That's the expression for the cost. Now, here's the key here. It says her parents, Shanique's parents, are willing to spend between 315 and 420. So how I would set this up, I would say 35h plus 175. That expression for the cost needs to be less than the 420 at maximum, but greater than the 315. Because she wants to spend between those amounts. So that would be the inequality. So now let's solve it. It says solve the inequality. What is the possible number of hours Shanique's parents can rent the bounce house? So kind of like I showed on that previous page, how I would do this, I would break it up into two separate ones. So I would say 315 is less than 35h plus 175. And then I would break it up into the other one, 35h plus 175 less than 420. And then solve them both. So I'll solve the one on the left first, subtract 175, 315 minus 175 is 140. divide by 35, 4. On the right inequality, subtract the 175, 245, I got, and then divide by 35, I got 7. So what this is saying is that Shanique's parents would, the hours to rent it would have to be greater than 4, but less than 7. So I would say between 4 and 7 hours. Okay, I'll let you do the rest.